Welcome to Energy at Large, the podcast where we discuss the power behind industrial infrastructure. Today we've got John Sharpe joining us. John Sharpe is an expert in the power design world. John's helped us on a number of projects. And John, would you mind giving us a little bit of your background today?
Sure. So I'm John Sharpe. I am a factory employee with Generac. I'm the director of National Power Solutions. That's my director title. I've been with Generac now coming on, actually next week, I will be on 13 years. I was 20 years in the Caterpillar network before that. So I've worked in the Caterpillar distribution network and then for Generac. Basic solely on generators. That's what I've done. For good or for bad, this is all I've done as a career. And I've made a lot of mistakes, but I think I've learned a lot from that. And that's somehow made me a subject matter expert.
Okay. Thank you, John. I think where we'd like to start today is your take on where's the industry going. So we hear a lot about battery energy storage, energy strategy, microgrids, even the failing grid as it sits today in the United States. From your seat, where are you seeing the industry heading?
Well, you hit on it, right? So it's I hate to be pejorative and use the word failing grid, but let's just use the word failing grid.
Sure, yeah, that's true.
Right. And that's the concern. The grid is to a certain level at risk, right? We need to do a fixed it 30, 40 years ago. We didn't. Now it's a little too late to get it fixed. There's a lot of not in my backyards. The grid is risking power quality and power availability to the end users.
I heard a statistic the other day that if you look out on a power pole out on the street, just on average, the transformer on those power poles throughout the United States are at least 50 years old.
Yeah.
Is that true?
Yeah, absolutely.
It's insane.
Yeah, it's beyond my recollection, but it's just one of those things where there hasn't always been an incentive to continue to revamp the grid. There's always kind of been this assumption like things would just be okay. And frankly, some companies just took what they should have been spending on the grid, stuck in their back pocket and moved on, did other things, right? And that has caused where we are today. I mean, let me get this straight. In like an 18-month period, I got snowstorms that knock out power in Texas. And then I get a heat wave that knocks out power in Texas. Make up its mind.
Yeah, wow.
Right? Either way, the Texas grid got beat up pretty bad, right? And that's just a small microcosm, a big microcosm of a national concern that we have, is that the grid is not going to serve the end users. Right? That model of, I got a big plant, a big nuclear plant, a big coal plant or whatever that's going to be here, and then I'm going to transmit data everywhere. Well, this transmission stuff is falling apart, and it's not going to get fixed tomorrow.
So what are you seeing? So if you're an industrial facility, and you're trying to future-proof your facility, what are some of the things that you think could be done in a kind of an energy strategy format? Or what should they be thinking about?
Yeah, and it's going to depend. You're right. It's an industrial customer. So let's talk about, these are typically when we talk about these folks, today we're talking about large industrial customers, right? This can be an industrial manufacturing plant. This can be a hospital campus, a university campus. This can be someone who's frankly consuming a lot of power, right? And power is only going to get more expensive and less reliable. So they're sitting there thinking, how important is power to me? And what's the best way I can make sure I get good power and I get power that I can manage the cost for, right? And it's going to depend on the user, right? The biggest thing they have to do is they have to understand who they are and what do they do with power? What are the things I can do, right? Everyone's, for the last 15 years, everyone said, okay, let's clean up our power. We'll switch to LEDs. That was great. Everyone did that. Now all the parking lots are LEDs and we're fine. What's the next step, right?
Sure, yeah.
And how am I going to make that better? You've got to understand your power profile. Do I use power 24/7? Do I use a lot of power 24/7? Do I peak during the middle of the day? Do I peak at night? And because there's a lot of different strategies based on your profile and what you're doing, right? So we can talk a bit about those if you want to go down that road.
Well, I'm wondering, so if you're a facility manager or you're the CEO of an industrial company, where would you begin? How do you even tackle this problem? You know things are changing.
Mm-hmm.
You're going to be facing unique challenges based on your circumstances. How do you know even where to begin? Do you do some sort of an audit?
Yeah, absolutely. I think an audit is the thing, right? We're going to start by understanding anyone who's going to want to have the conversation to help you improve your power quality, power availability, power reliability, is going to want to know your power profile, your load factor, your load profile. How much power do you pull in the middle of the night? How much do you pull during the day? The audit's also going to show you how important clean power is to you. It's not the same for everything.
Now, when you say clean power, are we talking about harmonics, like high frequency noise generated off a variable frequency drive, like current distortion? What do you mean when you say clean power?
Major swings in voltage,
Okay.
frequency support, those are two things that happen, especially if you're like at the end of a power line. Harmonics can be another thing, right? Having dirty power from harmonics. Also looking at having a bad power factor, right? Depends on the loads you have and understanding the power factor in your facility. Because when you're having bad power factor, you're paying for energy that you may not be actually using, right? You're paying for the phantom energy, the foam on top of the beer conversation. And so a power audit is the first place to start, just so when an expert you hire looks at something, they got something in front of them that speaks and makes sense.
I think that's a really important point. And something that I think most people probably know about is this power factor problem. Essentially, you're getting penalized for the power that is being supplied to you that you can't use.
Completely.
And we've seen that in our markets. Tyler and I have seen that a lot, where it's a pretty easy fix and the ROI is insane. It's less than a year most of the time to get that corrected. But sometimes people aren't even looking at their energy bills to see if they have this problem, these extra charges that are coming from the utility.
Absolutely. There's a little line item here that says, dirty power factor, and this is your surcharge, right? Putting in some capacitors in there is a pretty simple, low-hanging fruit thing that's going to make life easier. But looking at it like in the aggregate, you have to understand who you are as a power consumer. And also not only, again, what power you use and when, but how important it is to you. There may be, if you owned a campus network or something like that, there may be buildings where you don't care how clean the power is, right?
Sure,
but the biology research lab, you care, right? But maybe, the water treatment part, they don't care as much, right? So it's going to depend on who you are as a customer. What are you doing with power and how important is it at these different places? So then you can start to shape some solutions that'll work for you long term.
Yeah, let's talk about those solutions. Sorry, Tyler.
Well, I just want to break in. I hear from a lot of people, we'll talk about power factor, and people say, I don't really understand that. And we talk about all these power quality issues. Who could help them with that? Like, what's the kind of person you're looking to help you accomplish that audit?
Well, to start helping that audit, there's a number of people that can do it, right? We have companies that are in that power business, right? So you talk about folks who represent power quality cleaning devices who can put power quality meters, right? So someone like a power distributor, right? Someone like you guys, EMC, you've got the ability to go out there with a Dranitz or Fluke meter and give a characterization of what that power really looks like on a high speed level, right? You can hire a professional engineer that can come out and do an audit. Some of those folks will do that. So there's a number of folks out there, but I would start with someone that's truly in the power business, not somebody that just dabbles in it here and there.
Makes sense.
Great.
So I was just going to transition to the solution. So, there's a lot of buzz, obviously, for a lot of years about solar and wind. There's a lot of solar panels that have been installed. There's been incentives for solar. There's been incentives for LED lighting that you mentioned earlier. A lot of the low-hanging fruit has been tackled. So if you're a facility and you have this combination of, you have solar, you might even have just recently installed EV chargers, or new facilities are being designed with those. You have your backup generator. Maybe you're looking at other solutions like battery energy storage. What makes sense, and how do you organize all that? All those.
That's a
different
great question,
solutions?
right?
It seems like a headache.
Is to bring in someone who's familiar, because you're talking about different assets and what we're terming today to be a microgrid, right? And each of those assets brings something to the table based on what that power profile drives you to need, right? Am I trying to save money by just lowering my spend, right? Do I want to use less energy, or do I want to pay less for energy? Is clean energy what's really important to me? Is reliability and redundancy important to me? So as I'm putting those factors together, you can start to think what kind of assets are going to get there. Like a generator is a reliability conversation, right? A battery energy storage can be cleaning power. It can do speed, frequency support. It can do voltage support. It can also be a backup source, right? But now if we're also talking about saving money, depending on the utility or however you're buying power, there's going to be characterizations of those purchase agreements that are going to allow you to do some things on your end to avoid some additional charges, right? Peak shaving type things.
Well, yeah, we should talk about that for a minute.
Yeah.
So Tyler and I were at lunch today, and we're talking about, a tool, and I might have the name incorrect, but I think it's Imbala. And Imbala, I think, is involved in different states, specifically California,
Mhm.
that allows the utility to have access to a residential home's thermostat,
Yes, absolutely.
which is kind of unique. So basically, if I understand it correctly, during peak demand times, they're going to increase the temperature in your home
Mhm.
to help offload the power generation requirements for the area.
Absolutely.
Do you see something like that happening on an industrial scale where the utility is asking for, hey, we need to island your facility for a little bit. We're going to turn your generator on for you and run your facility off of your power system rather than our own.
Sure, absolutely. That's where things are going, right? And Imbala, Generac company, as we deal with that, right? Imbala is that software that a utility is using that's communicating to your thermostat that's made by Ecobee, another Generac company, so that you can then turn off your air conditioning, raise the temperature of air conditioning as we're moving along, right? So that's from a utility down, the utility trying to manage their own concern of the power that they're able to either produce or the power that they can handle over their network, right? And industrial guys, right down that same boat. Different brands of products, but similar profile, right? It's going to depend on what are we doing. And so the phrase I always like to use, the way I like to say this, and I think you're going, I hope this is where you're going,
Yeah, please.
is you have to have a conversation. I don't want to jump to the gun of solutions. We can talk about solution things, but you have to understand what is the business case. You start with the business case, right? What is your business? What is your load profile? Who are you buying power from? And what are the nature of those agreements, right? This is not a CapEx conversation. This is an OpEx conversation, right? I need to understand what are your constraints as a business? What are your demands as a business, right? I've got to have clean power here, or I can't shift my operations from this to that. So now that I know what those constraints are in my power, like, okay, what's available to me? Is it, peak shaving? Is it just being on a demand curtailment rate? Is it doing, time of use rates and managing a time of use rates? Is it selling power back to the utility if that's what the utility, right? If you're maybe an investor in utility, they don't want your power back. But if you are a municipality or a co-op, they do. So let's understand the business case first, right? And from the business case, that's going to then drive what we're going to call the use case, right? If you're someone who's trying to, what we're going to say, shift the curve, do a demand, or not demand response, but to do time of use. Well, if I could buy power in the middle of the night at 8 cents a kilowatt hour, and then avoid paying 35 cents a kilowatt hour in the middle of the afternoon when my processes are happening, or it's really hot and I got to run air conditioning or whatever's driving that, right? How do I shift that cheap power in the middle of the night over there, right? Well, that just tells you storage is kind of probably the way to go, right? So with battery energy storage. So it's understanding first their requirements and their business case that then drives what solution and when would I run it.
Well, I really appreciate that. I think it's very insightful. From our seat, so at Energy Management Corporation, we operate electric motor repair facilities. We manufacture variable frequency drive control systems. We're in a lot of different industries, from mining to oil and gas to municipalities.
Mhm.
But one commonality that we've seen is almost 100% of the time, the highest capital cost or operating cost
Mhm.
for any of these entities is the cost of power.
Yeah, absolutely.
And getting a handle on what unique solutions might drive strategic sense for them is just imperative right now.
Absolutely. And that's what you've got. And you've got to understand who this guy is and where they're like, who are they connected to for power?
Yeah.
And what kind of agreements are they getting for power? Like, am I just paying a transmission fee to a local guy I'm paying the network transmission fee, and then I'm buying some wind power out of Wyoming, right? Because I feel better. I want to get some green power. Or I don't care and I just want to buy from my local utility. And so I'm buying straight from them. And then mid-transmission fees are included in that. How do I want to make that happen? And once I understand those agreements from a financial standpoint, I can start looking at what things can be in place to reduce that, right? Can I produce my own power? Do I just want to store power? Like, can I produce my own power putting some solar on, right? That's an easy box that people try to do, but I got to have real estate, right? Because solar takes up real estate. So you're on the roof of the building, you're on the roof of the parking garage, you're on wherever. So is that a solution for you, right? Battery energy storage, like I said, There's a lot of things you can do with that. Shifting curves, one of those things. We start talking about using EVs. One of these days, EVs is going to become one of those things where we're charging people's cars and everyone gets charged up to 100%, like, I don't know, 9 o'clock in the morning when power's cheap. And then at 2 o'clock in the afternoon, we're going to take you from 100% in your car back to 80. We're going to take that power back out of your car. We're going to use your car as a BESS to take some of that power back.
That's a really interesting take. I haven't thought about that. Have you thought about that before, Ty?
No, I haven't.
What's going to happen?
That's interesting. Using the EVs as a battery.
Yeah.
For the grid.
You're going to do it at home, and eventually we're going to do it in the industrial world too. Absolutely.
But real quick, just you said something there, and we've talked about it a bit. Can you just step back and tell us, what does BESS stand for? What is that term we keep
So that's
using?
battery energy storage systems, right? And today what we're looking at, there's two different ways to talk about battery energy storage, two different worlds that we live in. There's the utility scale behind the meter type, right? That's where they may be putting out in some field in the middle of nowhere, a big solar farm and a bunch of battery storage out there where they're doing like 200 megawatt scale type stuff, right? That's all utility world stuff. The second is to get customer owned stuff, which is then going to be behind the meter, right? Or in front of the meter, sorry. So that's going to be on the customer's property. And that's, you're going to use that battery to store up energy to then determine when you want to let it out, right? When's the best time to do so? And depending on your load profile, you're going to understand, am I doing this, like I said, to clean my power up, to improve my power factor, right? A battery energy storage has something called a two-way inverter. That two-way inverter allows us to clean up power factor to a certain level within that device, right? It's plugged in all the time. It's plugged into the utility, and it's either doing what we call grid following or grid forming. But when it's in grid following mode, it can help you manage your power factor in your building, just like putting some capacitors in there.
And another term for that is probably leading or lagging power
Correct.
factor correction.
Right. So there's power factor correction that's built into that. So that may be the thing, right? But then you've got a program to say, well, at 2 o'clock every day, we want to run the air conditioners more, or we have some batch process that happens at 2 o'clock. We're an industrial plant, right? And so like, oh, well, when that process happens, we want to be using battery storage so that we're not consuming too much power from the utility, right? And that might help us do some sort of peak shaving, or like I said, doing your time of use, shifting that time of use to cheaper.
It all sounds amazing, but it all sounds complicated.
It is complicated.
So obviously, there's solutions out there.
Sure.
And Generac has a solution out there. So if I'm a facility owner and I've got solar on the roof, I've got EV chargers going, I've got a backup generator, maybe I even have a battery energy storage device in my facility. I want to come up with some game plan to operate effectively, to take advantage of to take advantage of the rates that are beneficial to my facility. What solutions how does that, Generac has a microgrid controller.
Right. So we have a microgrid controller.
Talk to us about the capabilities of that. Like, how does that make it easy for somebody in that seat?
Sure. So, and that's what we do. So Agito is the name of the company that we've purchased that does our microgrid controllers, right? And truly the process, if we've already got assets in place, we're going to have a conversation about how those assets, how they interface with one another, and when each becomes a primary, and how do they manage it from there. And it can be a reasonably extensive conversation to have, but it's truly, if I've got solar and I've got wind and I've got the utility and I've got battery and I've got EV and I've got a generator, each of those plays a part in the overall world of this microgrid that we're putting together.
Sure, yeah.
Right. But solar's only good 10 to 2.
Sure.
Right?
But in getting them to play when you need them to play is...
Yeah. That's what the microgrid's going to do for us. That's what the microgrid controller, and it takes some work, right? I mean, there's a whole lot of programming that goes on behind it once you've sat down and worked out your sequence events. And that's what a microgrid controller will do for us. It will talk to solar, and when solar says, hey, it's a bright day and I can produce more, we've got to shift everything maybe away from the utility over to the solar. But then if it's a cloudy day, maybe I've got to shift back to the utility. Or maybe it's just an intermittent cloudy day and I can ask the battery to support a little bit until the solar comes back, right? And so the microgrid controller talks to each of those as an output device and determines when's the best time.
And it's making decisions and changing on the fly.
Absolutely.
That's incredible, yeah.
It's incredible, it's scary. Yeah. Now, what it does, I want to be very clear. What it doesn't do is it's not watching energy markets and telling you, oh, that power you're buying in Wyoming has just got more expensive. You need to go to your BESS, right? It's not, it ain't going to do that. It's
Sure.
going to do a lot of things for you. It is very smart. But it doesn't monitor energy, spot market energy things and do things for you. But it will give you, a defined sequence that says, if this is available, this is primary. If this is not available, or if the one that's primary is compromised, like solar, it's a cloudy day and I'm only getting 60% power instead of 80 or 100, what do I do? Right. So you work through all of those sequences, and then it's programmed to tie those sources together and give you the best outcome based on what resources and assets are sitting there.
I hear from a lot of customers that energy, we talked about energy costs are going to be your highest line item on
Oh, yeah.
most. But I've also heard downtime could be just as expensive. So do microgrids help with reliability, or is it just purely financial savings?
Oh no, it can absolutely help with reliability, right? Because it's going to depend again on the assets that you've got, but it knows it's talking to each processor that manages that asset, right? The solar has its own inverters, the solar has its own controller. The BESS has its own inverters, it has its own controller. The generator obviously has its own. Each of those have their own. And the way you're going to set up the use case is you're going to do a hierarchy. The generator is usually at the bottom, right? It's your fail-safe. The generator is the last thing, but it does help make sure that you're continuing to get continuous clean power throughout. And then if all the world's gone a bad way, the utility's gone and it's a dark day or it's at night and we've depleted all the batteries, start the generator, get going. Like, yes, it absolutely makes those so that you're always getting reliable power coming through.
I'm sure there's some facility owners that are listening to this and thinking that is a product I need.
Yeah.
And it's not specific, to be clear. It doesn't have to work on a Generac generator or a Generac
No,
product.
vendor
It'll work
neutral.
with anything.
Absolutely. Doing a project today in Virgin Islands. We're working with Schneider. Schneider's actually doing a lot of the controls, and we're involved in that.
Yeah.
We don't make solar as Generac. That's not our thing. We're involved in microinverters for solar panels, but we do not do solar. There's no point. There's plenty of solar guys out there in the world, but we talk to everybody's solar stuff.
So it doesn't matter. So you
Doesn't
can
matter.
have solar system provided by ABC company, generator provided by another company,
Mhm.
battery energy storage provided by somebody else. You can still make all that work together.
Absolutely. Absolutely. And then it takes a lot of upfront work, a lot of meetings. You're going to check a lot of boxes, but once you get through all that, everybody's stuff, it doesn't all work exactly the same, but in general the same. So you just have to understand how their communication platform is and how that microgrid controller, which is the brains, right? It is the conductor of the orchestra that is managing everything and telling everyone when they're supposed to be doing what they can do.
Pretty awesome.
So are these microgrid controllers? I hear a lot about remote monitoring, condition
Sure.
monitoring. Is it similar, or do those just kind of pair up with those type of
They
products?
pair up with one another, right? They're different things. And again, remote monitoring becomes one of those things. I think our product here would be Generac Link, is something we use as remote monitoring. It talks to our microgrid controllers and some of our other components. It's going to depend on what the customer wants, but the microgrid controller is, like I said, it's the orchestra conductor. It is there on site to tell all these assets, what is my responsibility? What should I be doing? Right? The remote monitoring becomes the checking to make sure that everything is working as efficiently as it should, right? If I've got a generator that's running and suddenly I'm starting to see a drop in fuel pressure, tells me I've probably maybe got some dirty fuel or dirty fuel filter. Probably should get out there and take a look at that, right? Or if I've got solar and solar never seems to get where it's supposed to be, but it's a beautiful sunny day, maybe that means I've got some inverter issues. The remote monitoring helps us to manage what's going on, give the owner a view into everything and understand what's going on. Now, that also can allow them to, frankly, override the microgrid controller. That's what I'm saying about watching markets, right? If you're buying energy on the spot market and you suddenly see that things have gone really bad and you want to go to a different asset because of that, they can override that with remote monitoring. It will talk to the microgrid controller, right? But it is all fully, off-site type stuff.
That's helpful. Tyler and we were on a site last week, and I'm wondering how these two solutions could have potentially worked together and solved this problem that we heard about. The scenario was they had a large generator and it had a 7-day tank to it. It was a diesel generator.
It's a lot of fuel.
A lot of fuel. And so they're not sure what happened. So the maintenance folks, that we were speaking to the maintenance folks, and this generator turned on and transferred and was running the building.
Mhm.
They didn't know. they didn't realize. The way they found out was when the generator ran out of fuel and the building lost power. So in that scenario, just the cost to refuel the generator made them reach out to us for some sort of remote monitoring for the genset.
Yeah.
But in this scenario where maybe you have both solutions, you have the microgrid controller, Agito,
Mhm.
and then you also have the remote monitoring, Generac Link.
Mhm.
How would that have saved them in this situation? We're talking about thousands of dollars of diesel fuel that
Oh, certainly.
they didn't need to spend.
Well, yeah. That's terrible. That's a lot of fuel. That's a lot of waste.
You know,
But that's where the remote monitoring from the Generac Link, right? It's going to talk to the microgrid controller or talk to the asset that's on site. And when you start getting the simple thing is to say, if my fuel price, I've got alarms and I've got pre-alarms and I can text somebody, I can email someone. So that Generac Link is not only a portal to be able to look at stuff, but it also can actively do outreach. They can send a note to the owner. It can send the owner to the owner's representative. It can send a designated dealer, right? So like we have, also Generac has in the residential world, right? We have something called Mobile Link. So a residential product. I have a home standby generator. And when my home standby generator runs, it sends me a text, it sends me an email. And if I went to the Mobile Link app on my phone, it would tell me my generator is running. So every Wednesday at noon, when my generator exercises, it 3 different ways tells me that's happening. It also knows the company that I have as the servicing company is tied to that. So if there's an alarm or a pre-alarm on my generator, it will send an email and a text to those folks, and they will know that I'm having this problem as well, right? So and you can set it up any way you want. You could send a text to someone every time the generator runs, so then when someone at least knows it's running, right?
Yeah.
Why am I running?
Yeah.
I don't know why I'm
In
running. It's Tuesday
in
at
this
3.
case, they were surprised. They said, we were in the building.
Yeah,
We're surprised we didn't hear the generator running, but we didn't.
that's a good generator enclosure. Is what I'm thinking. But no, that's the thing that happens. That's totally fair. I had a customer run one all the way through the weekend, and fortunately it was a gas unit, so they never actually ran out, but it never switched back to utility. Well, like, why didn't you switch back?
Yeah.
But those are the kind of things that those tools can use, and then in the bare simple alert people to what's going on. And you can even have a hierarchy that says, listen, you tell these 4 people when the generator is running. If I start to get a pre-alarm, you add these 2 people to it, as well as maybe your servicing dealer as some sort of an automated knock system, right? That's going to go, and so maybe you as EMC are going to have an on-call service technician that's going to carry a pager or a phone or something that gets rerouted to them. And whoever that on-call guy is, at Saturday morning at 2 a.m., gets a call that says this generator is running and it's in trouble, right? And now we need to go out there and do something about it.
Sure. The way we're using this at EMC is we're structuring, obviously we're doing preventative maintenance and load baking on generators, brand neutral. And we're structuring this to where if the customer would like EMC to automatically dispatch a technician based on the criticality of the alarm that comes from this controller, that's part of the agreement. And so we have negotiated rates, so we just send a technician right out depending on the severity of the alarm. Or if it's not that big of a deal, we'll make a phone call.
Yeah. Well, and that's the thing you want to have with your customers. You want to wrap that serviceability and that capability in the customer. We said this earlier today. No one wants a number of the things we sell, right? A standby generator is insurance for your business. Either code requires it or you're doing it because frankly, you don't trust your power enough and your business is so important, you need to do it. But it's a pretty expensive capital piece of equipment that sits outside in the parking lot, eats up your capital and your lending capability of your business.
It doesn't get used hardly
and it doesn't
ever.
get used and no one wants it. Life insurance, no one wins until you're dead. So it's the same kind of thing, right? So one, it's a capital expense that somebody's paid a lot for. So they want this thing to work. They want it to be reliable. So it's important to be able to handle it. But at the same time, they just want to make sure that it's always going to work, right? So that you have agreements. You sit with these people and you say, if this is not going well, I'm here to support you. And here are some things we can put into place, some technologies into place, some assets into place that are going to improve the reliability of this very expensive capital asset that you have put into your facility.
You know, as I've looked at this, the pricing of it, it's not that expensive.
It's cheaper than my cell phone.
It makes a lot of sense to take a look at this.
Yeah.
Especially when you run into certain situations. We have an office in Las Vegas, and a few years ago, one of the main casinos down in Las Vegas lost power, and
awkward.
awkward for sure. Their generator didn't fire. It didn't start when they needed it. So we're looking at a fairly, not just fairly, it was a significant loss of revenue for the casino,
Sure.
and they were quite upset that it didn't run. So as I look at the potential cost of this system that's reliability based, it's based to keep you going if something happens, you've paid for it, and then it doesn't work when you need it. There's almost nothing more frustrating.
True. Absolutely.
And so I'm really, really excited about this new remote monitoring device
Yeah,
that's out there.
it's just another step in a very, like you said, it's a really inexpensive step to take a certain level. And that's the good thing. You take a certain level of ownership of this thing that you didn't want to own in the first place, but also to know that you've got a partner that's going to help you take ownership and make sure that it's working in real time,
Yeah.
right? That it's not just one of those, well, it didn't run and we called somebody and they were able to be out in like 4 hours. We knew the fuel filter was failing earlier because it was clogging, and we've given you a low fuel pressure pre-alarm, or we've watched a trend go on, and we can program that kind of stuff, and then we can send somebody out before it shuts down, right?
Yeah.
And that's the kind of stuff that you want to get into, having some more prescribed maintenance or recognizing some trends and doing some maintenance based on that.
I'm wondering if now's a good time to transition into fuel types. So as part of the energy strategy plan that somebody might have,
Mhm.
we've got an office in California, just outside of Los Angeles in Pomona. If I'm buying a generator in California today, if I need one for my facility, I can meet the requirements of air quality by buying a tier 4 generator. But I'm scared that in 5 or 10 years, that's not going to be good enough. The unit that I bought today may not be good enough in the future. So I'm going to be looking for other sources. What are your thoughts on that?
That's a good question, right? And so you've got any owner, this is the difficult part, and we're going to get into the weeds for a moment here, but any owner is going to have to understand what are the circumstances that they're in today. At some points, like you said, if tier 4 isn't good enough today, there's a whole lot you can do if tier 5 comes out 7 years from now, right? Or whatever that is. You hope that you're going to be able to get in under the time window of a clause or something like that. But you said, yeah, things change. What do you do?
Yeah.
So what's the level of criticality of need for your piece of equipment, right? You're buying this, means you really want it, right? You're protecting whatever it is you're doing. How involved of an owner do you want to be? Like if you're going to go down the diesel road, right? Diesel, I've got to maintain the fuel. I've got to make sure it's full of fuel. If the fuel goes bad after a couple of years, I've got to replace it. I need to understand that those are expenses I'm going to have to deal with, and that's just a part of what's going to happen, right? You don't have a choice, right? That's the nature of owning that piece of equipment. These are responsibilities that come with the burden of that.
Inexpensive. Like this facility we mentioned earlier with the 7 days worth of fuel, they've got a very expensive fuel polishing system.
Yeah.
To make sure that diesel fuel hasn't.
It ran for 7 days. I think it worked.
It worked great.
I'm good. No. But here's the thing, right? So you get into, and you're never going to know, right? You can never test the political winds of how things are going to go, right? The winds shift all the time. And that drives some of this behavior as far as when something's clean enough or not clean enough and how much farther can you do. I could sit here and say, well, if you're in California, if you're concerned about tier 4, I could go to a gas unit, right? Gas unit's going to be cleaner, right? A diesel unit is oxides of nitrogen that we care about. So we prevent oxides of nitrogen turning into nitric acid in the atmosphere, causing acid rain. But at the same time, if I've got a natural gas piece of equipment, I've got to deal with carbon monoxide, right? So that's the byproduct of burning natural gas. So it's a different effluent, similar thing, talking about global warming and carbon monoxide. I've also got to deal with, though, natural gas. If I'm in California specific, right? I get an earthquake in California, they shut the gas off. So if my issue is a seismic issue and gas was my thing, I don't have any gas anymore, right? So that's kind of a good point to bring up in California. So now I got 2 of them I'm not sure I trust.
Yeah.
I got this diesel that could change over time, and I got the gas that could be shut off tomorrow.
I think that's a big problem
Right.
that people face is they're making a decision. I think a lot of times they think natural gas sounds like a great solution. I don't want to deal with the diesel on site. I don't want to clean it and polish it, but I need the generator when I need the generator. And if I don't have gas, I'm out.
Yeah, 49 other states it's pretty good at strategy, and one of them it's not, and that's
Yeah.
just that's just the nature of that
Yeah,
state and how things work. And so I'm not pejorative against California, but that's just a function of that.
sure.
So you've got to think, what's my next thing, right? And maybe I've got to have a generator with supported by battery, right? So now I've at least got something to get me through for a certain amount of time, right? So you may be forced in that particular atmosphere of California. A generator's great, but a generator isn't going to be overall as reliable long term because you have fuel issues. You've got fuel that gets shut off. So there may be another asset needs to be brought to fore to help support the whole thing, right? You're not going to be that way everywhere. If you're not in a seismic area, gas is a perfectly reliable thing to do, right? The other good thing about gas is the leap from being in what we call an emergency use unit to a non-emergency use, right? Emergency is cleaner, non-emergency is actually emergency is dirtier, non-emergency is cleaner, right? That cost leap, that technology leap is not very big. So now you could maybe take that generator and try to offset your capital costs by doing demand response programs, peak shaving, that kind of stuff. It takes you down those roads.
For somebody that's not familiar with demand response or peak shaving, do you mind explaining that?
Sure. Yeah, here's goes. So we'll start with demand response, right? So demand response and curtailment programs. A lot of things go into this umbrella of demand response, but they are different. Demand response and curtailment programs are usually where you as a customer are signing an agreement with the utility to give them control of your piece of equipment, or they're going to send you a note, right? And what it is the grid says on a really hot day, the grid is in trouble, recognizing that everything's temperature based, right? Load goes up as temperature goes up, but also the current carrying capacity of the grid goes down, right? As conductors get hot, they can't carry as much capacity. So the grid gets worse on a hot day, on the day that the load gets greater because everyone's running their air conditioning, right? So the grid's like, I'm in trouble. I'm at 95% of my capacity. I need to get some load off. So it's a curtailment or demand. Like, I'm going to call these people or send a signal, get your facility off my grid, run your generator. And they're going to pay you a nominal amount of money to do so, right? They're not going to pay off the generator in like 1 year kind of thing. But it depends on the agreements. I've seen them anywhere from like $6,000 a year to $60,000 a year to help pay for this piece of equipment. But they have the right to be able to run that. But you have to have the cleanest piece of equipment out there to do it. You can't just do it with a regular emergency standby cleanliness piece of equipment. Peak shave is a little different, right? Everyone understands the typical load profile is that you have a low load in the morning, right? And as the day gets warmer, your air conditioning runs more, right, during the summer, and you have this peak in the middle of the day, right? So around 2 o'clock to 6 o'clock each day, that is an overall peak for your facility that you're managing. Coincidentally, that's the overall peak for the utility that you're connected to as well, right? They see a low load in the morning and it gets worse. So because they got a bunch of customers that are just like you all have the same load profile. So what they do, if you look at your power bill, you're going to see an industrial customer with an industrial rate. You're going to see two different energy charges. One is an energy usage charge, or kWh. That's energy consumption. How many amps did I burn through? How much energy did I burn in an aggregate for the whole month? Okay. But you don't really know if I used the same amount of energy 24/7 for the entire month, or did I have this swooping thing going on? That doesn't really tell you anything, but that's where you pay so many cents per kilowatt hour. There's a second part on that bill, though, that's called a demand charge. And that demand charge is where the utility is charging you for what you might need. Because on Tuesday, last year in March, you used 1,000 kW because it was a really hot day and you burned all your air conditioning or something went wrong. And they're like, so you have the potential to use 1,000 kW at any instant time. So for the next 12 months, we're going to pay you in case we have to provide you 1,000 kW at any given moment, right? So we're going to charge you for that. So there's what's called a demand charge, and it's by kW, and usually it's a monthly charge, dollars per kW, and it's billed on a rolling 12-month peak.
And I think it's on a 15-minute average.
It's a 15-minute average. Absolutely.
So we get questions sometimes about, I've got this big motor. We had an indoor skydiving tunnel we helped design and
cool.
And it was in California, and they were saying they had massive motors, 3,000 horsepower motors running this indoor skydiving tunnel. We wanted the owner wanted to be the most powerful indoor skydiving tunnel in the world.
Sure.
But he was concerned about just turning that on and off.
Yeah.
And the challenge there is it's on this 15-minute average. So it's not necessarily just that inrush current as it turns on.
In the
That
inrush,
momentary.
the utility doesn't notice that. They don't see that because that's a 15-minute kind of thing.
Yeah.
The snapshots they don't see. But it is one of those, as you keep building loads, that peak gets higher and higher. And that's what they're going to get you for, right? And so what you try to do is you say, well, on my days where I use a lot of energy, right? And maybe it's just Monday through Friday for my business, from 2 o'clock until 6 o'clock, which are my peak times, I need to run my generator to either take the entire building offload or just lop off that top. So there is no peak. It just stops here. The peak is absorbed by the generator, right? And by doing so, instead of having 1,000 kilowatts of load, maybe I'm only getting 500 kilowatts of load, right? And that's money that I'm saving off. So I'm shaving the peak off. That's what we mean
Do
by
you see
peak
that
shaving.
actually make financial sense for somebody? Like, is it a big noticeable thing?
Going to do a little story time for you, children. All right. So back in the day when I had hair,
That's going way back.
These are going way back. We're talking about 1994. I worked on a customer. So a customer was it was a food processing plant, very large food processing plant, and they were on a local cooperative that had them on a peak shaving plant, right? So they had a plan where they paid a lot more for what they burned during the day, right?
Okay.
And it was either $18 or $20 a kilowatt hour was what they were getting charged. These people has massive processing plant.
$18 or $20
is $18 to $20 a kilowatt hour.
Yeah.
Right. So you start thinking about it. If it was 1,000 kW you were shaving, you're getting paid $18,000 to $20,000 a month. Right. So that's what you're saving in that. So these guys put in. I got to put in the second plant. The first plant was already there. We did 11 1,500 kW generators at 4160 volt. Right. So I had 16,000 kW of power. We put that plant in with paralleling gear that syncs with the utility and backed up, and not only backed up, but peak shaved for this processing plant. It paid for that entire plant, which was like $3.5 million. Today it would probably be worth about $12 million.
Sure.
But it was like $3.5 million worth of stuff paid for in the first plant paid for itself in 2 years. This plant paid for itself in 15 months.
Holy cow.
Right. And after 15 months, these generators still got 20 years of life.
So it's real money, but it may be
Real
money
money.
that people, it's overlooked.
Yeah.
It goes back to the energy strategy discussion and why
Correct.
there's not really a one silver bullet to solve the whole problem.
Right. So you were asking earlier about like, where do you go? And it's one of the tools that we use within the Generac world, within our grid services world, is if we have your load profile, we start talking about assets. And we know who your power provider is and what rates are available for you. There's software out there. It's called Zendy, right? it's not Generac software, but something we do use, that we will help model your whole thing and start looking at the different utility rates that are available and understanding which rates make most sense for which assets. So Zendy actually does that math. It's got a huge database of utility rates, right? Because every utility has 50 different rates and riders and whatever, right? So it's a massive database of whatever they've got. And they can tell you, well, if you've got this customer, if you're on Nevada Energy or a Duke Power for me, like, well, Duke has this rider where if you do this, you can do this, right? So they can say, well, they put you on a peak shave rate. If you want to go in here and shave that peak, lower that demand, they'll let you do it, and it'll help you do the math. So you got to understand there's good rates and there's bad rates. I say good and bad, not that there's bad rates, but it's just there's good rates that'll help pay for things. There's rates that won't.
Sure.
Right. So you got to understand where you are, what's the nature of the power provider, and what kind of rates do they put in place. That can go way back to our first part of the discussion, which was, you got to know your customer, you got to know their load profile, who their power company is, and that Zendy will help you model that stuff. Right. And then it says, well, yeah, you would save $10,000 a month. Right. And then the math is easy. We go get a generator, we put it in, life's cool.
So if somebody came in, they worked with their local industrial Generac dealer, you're saying that dealer has the access to these tools to help somebody through this conversation?
That dealer has access to people at Generac who have access to those tools.
Yeah.
This is not a conversation you take easily and lightly and that everyone's going to be able to have.
Yeah.
I got to be honest with you. I reasonably know this pretty well. Like I said, I've been doing this now for 30, 40 years. And there's still plenty of things that I don't know that I could do, but there's people who know this software and can help model the whole thing.
Yeah. Right.
And so we get it to those right resources, and then they come back and say, these are the things we think would fit your profile and help you the best.
Also, speaking of software making lives easier, I know Generac's got a pretty cool tool with Power Design Pro
Mhm.
that can help make engineers' lives a little bit
Yes.
easier. Could you tell me a little bit more about that?
So Power Design Pro, for those who aren't familiar, it's a tool we've had in place probably for 15 years. Originally was a tool that was PC based, and now it's web based, and it is something that we are providing to it's a free tool that we provide to the engineering design community to be able to then model what they're doing. I say model is probably not the best word, but you're able to insert loads that you expect to run in a facility, and it's going to tell you what size generator it takes to start and run those loads, right? You've got to understand the nature of those loads. Like if you're a design engineer, you probably want to get some of the spec sheets on the product you're designing around. I don't mean the generator. I mean, if I'm doing a bunch of pumps and motors, right? Or VFD drives or whatever, I want to know what's the harmonic,
Sure.
output of this, how bad is the noise going to come off of this drive? Is it a drive from 25 years ago, so it's going to be 20% harmonic, or is it something new that's going to be 5? Right? Is it 6 pulse, 12 pulse, 18 pulse? So we can help figure out how big of a generator. It's not. I wouldn't call it building modeling software. You don't walk through a building and just do an inventory of 94 different loads and regurgitate that into the software and expect to get a good answer, because the software is not smart enough to know when this runs and that doesn't. Right? It's not that smart of a load, right? So you're going to want to do it that way, but you want to understand what are the things that I'm really going to be running on generation, and it will help you produce the right solution. And you can toggle between, is the gas generator, how big would it be? It's a diesel generator, how big would it be? You can understand the windows of operation. The pump station in the middle of nowhere can handle some dirty power. A motor is a very robust load. It can take some abuse and still work fine. Just talking about a motor as a cross the line start motor, you can beat up a motor pretty hard and it doesn't care,
Yep.
right? A VFD cares, right? A soft starter cares. The equipment in the emergency department of a hospital really cares, right? So you have to understand what is the acceptability bandwidth. You can modulate those to then give you the right solution, right? It helps you analyze harmonics. It helps you do, gas supply analysis. If you're doing a generator, you can understand, well, like, what size pipe do I need? I can do exhaust piping if I'm going to be doing that. If I get a 10-foot or a 50-foot run of pipe, how big of a pipe should it be? And at the end, we're going to give you a solution, right, that we think fits the need. We're also going to allow you to produce a bid spec, right, a document. So if you're going out to bid, right, it's in the AIA or American Institute of Architects in their standard format, that 3-paragraph format. So you can take that, print that out. It's a Word document, put it right into your bid spec. We do that for transfer switches and battery energy storage as well. So it's a pretty flexible tool that does a lot of things to help you understand what's the best generator solution for your facility.
No, I'm sure somebody listening is thinking that is a powerful tool. It's a tool I'd love to use, but I'm not going to use it because I probably have to put in my information, and then I'm going to get a whole bunch of sales calls, people bothering me after I use the tool. I know that's not the case, but
Yeah.
explain that to us.
Well, that's the thing. And
Yeah.
I have to be very frank. Your data as a user is your data, right? This is your intellectual property. The people who use this tool primarily are professional design engineers. And it is not our business and our practice to look over your shoulder and bug you over your stuff, right? It is our tool. We house it. It's on our servers. We own the whole thing. Do not get it wrong. If we really wanted to get nuts and go into it, we could go. But we don't. We have made a business decision that says this is our customers' data, customers' information. And if you size a 500 kW generator, you are not going to get a phone call tomorrow that says, hey, saw you size a 500 kW. Let's talk. No, that's not going to happen, right? We have to respect your privacy. We have to respect your IP. And if you want help from us, there's a button that says need request for help or request for quote. Okay. Actually, there is another button that says a share button. I always want to remember to mention this. If you're struggling, because you don't use this tool every day. I do. Most people don't. So if you're not really sure of what we've done with that, there's a button that you can share, right? You can put in john.sharpe@generac.com and forward this with commentary and say, this is what I've put together. Because if you pick up the phone and call me and say, I'm not really understanding how this works, my problem is I don't see what you see. It's very hard for me to process what's on your screen from over the phone. But if you share it to me, and now I see all of your loads, you and I can have this conversation because I'm seeing exactly what you see. And in the vein that you're going down, we do not allow someone who is a receiver of a file to then do anything else with it. If I want to make my own version, I can't change your stuff. I can make my own version. And if I make my own version, all I'm allowed to do is send it back to you as the author, right? I can't forward it to someone else at all. It is your stuff. You share it with me. I say, let's look, instead of a 6 pulse, let's do a 12 pulse, or we'll do something different, right? And when we do, let's take the incandescent lighting and turn it into LED. We change a few things. All I'm allowed to do in the software is to forward it back to you, right? That comes a lot from some European IP laws that we think are a really good idea. And so we're practicing it here as well, is we're not going to stomp on people's data because it's their information. It's just our tool. It's your data.
Yeah, that's great. I'd like to transition a little bit to, one of the major changes and shifts we've seen over the last 12 or 24 months. It has to do with data centers, has to do with AI. Well, it's been discussed almost ad nauseum, but it is reality. There's a lot of changes that are happening because of the demands of power that are from AI. But in the data center space in particular, talk to us a little bit about what you've seen there that makes sense. Maybe where does Generac fit in that space? Versus, we see a lot of these data centers coming out, and it seems like the power requirements keep getting higher. They used to be 1 megawatt units. They'd be parallel. There'd be a whole bunch of them. Then it went to 2 as a standard. Then it's gone to 4. And I'm just not sure what makes sense anymore. It just seems like those power requirements just keep getting higher.
Then it's not going to change.
Yeah.
Right. I mean, it's truly not. And well, actually, what's going to get better, I could go down this road, but liquid cooling is going to make life a little easier on that if you invest in the liquid cooling for servers and stuff.
That is,
but
you're
right.
Crazy. That video, I saw that viral video where they're submerging the electronics in liquid, and it's amazing. If you haven't seen
intuitively, it just
doesn't make sense.
It's just wrong. No, you bring the point, right? So what happened? And again, another history time, children. I didn't have hair at this point. So like 15 years ago, I worked on a project. It was 7 2-megawatt generators, 15,000 volts, backing up a data center for a bank. And you paralleled all the generators together. This is old school traditional, right? Big paralleling switch gears. This is a multi-million-dollar job. And they've got 7 generators, and they all parallel together, and then they all feed all these data halls, right? And the way this was coming about was they were going to build 4 of these data centers, identical. And the southeast one and the northwest one were going to back each other up, and the northeast and the southwest were going to back each other up, right? So they had 4 of them, and they had some level of built-in redundancy. And back in those days, I'm talking about 2006, 2007, equipment redundancy was the thing, right? It was like, I'm going to build a redundant data center to back up this data center, right? And kind of this, and you had generators parallel together, and you did this. And somewhere along the way, software took over, right? Guys at Cisco Systems, and I can't remember the name of the company that they work with, but they started getting software to take over servers, software to take over UPSs, and they realized this whole paralleling thing really wasn't where they wanted to go. What they did is they changed to servers that can be dual corded, A and B corded. So now we don't parallel generators at data centers anymore. What we do is we do what's called block redundant, right? So these 2 halls back each other up, and there's a bunch of servers, and they're plugged into each side. And if this side takes a dive, well, then they just start pulling from here. So you never load one more than 50% of the other, okay? And that has really allowed, so now that gives the data center different levels of redundancy, because now it's redundancy by hall. This hall can be backed up by this hall, and they back each other up, right? So that was the first thing that happened. The next thing that happens is they start breaking up the data. They fractionalize the data. When you take a photograph in Facebook, you upload it in Facebook, that photograph file doesn't go to a server in a data center. It goes to 6 servers in 6 data centers, right? And only parts of the file go to each place. Depends on, latency and speed, how close things are together. So they have to then, when you call that photo back up, it's got to go, well, parts of it over here, parts over here, and parts over here. But now these servers, these whole buildings are redundant to one another, and the server does it all. All these servers do it all. So it's really crazy smart stuff, right? And that's how it goes. But in order to be that smart, you got to burn a lot of energy. And so that's where these servers are now going more and more. Now we're going to get into AI. And AI is going to be I mean, that's the thing you're seeing, right? It's ad
Yeah.
nauseum, every article, it's AI
Yep.
this and AI that. And I get it. And so now when you may, I think the conversation was if you used to do a Google search before and it used X amount of data for a Google search, right? Like, where am I going to dinner? And it was a Google search and it used so much data. Today, you ask it and it's in the AI, you're going to use 17 times more power. I think it's 17. But it uses a lot more power through that AI to answer that same question. So if you think about all these data centers, we're going to have that much more data centers as we use AI, because AI is going to give you a much more thorough answer. It's going to do much more research, then it's going to formulate a response, and then it's going to give it back to you. So there's a lot of thinking that's got to go on to get you there,
Sure.
right? It's not just call and answer. And I find a bunch of things that seem to be similar to what you're asking. So those are what I'm going to give you. That was what a Google search used to be. Now it's, oh no, I'm going to look at all these answers. I'm going to figure out which one's the best. I'm going to write you an answer back. You're going to get the whole thing, right? And that's what AI is doing. And that thought takes a tremendous amount of energy. And that's not going to slow down domestically anytime soon, right? We're
So-
seeing lead times years out because of what AI is doing to the demand of this
I mean,
market.
it's incredible to see the effects on just as simple as transformers. Transformers were a problem during the pandemic,
Sure.
but they're just as big of a problem today, post-pandemic, because of the demand from data centers.
Yeah.
We're looking at well over 54-week deliveries on a lot of these transformers right now. As far as Generac playing in the data center
Mhm.
space, where do you feel like Generac is strong?
So, I mean, in the data center space, and we've talked to all those players, right? Generac is rolling out a new product line for us. This is our very large product line. So if you're familiar with Generac today, right, we stop at 2 megawatts of a diesel product. Well, we released this week the preliminary documentation on our next generation of large generation, and that is going to be generators that start to 2250 kW and go all the way up to 3250 kW in a single product, right? So that's a 66 liter, and I think an 88 liter engine that we're rolling out into new products that we'll have available, I believe, in fourth quarter of this year.
It's incredible, especially when you get into these sizes. Data centers, we're talking about paralleling these units together. It might be helpful for some to understand Generac's history in paralleling.
Well, Generac is, thank you. That's a great place to talk. Let me make sure that everyone understands when we talk about paralleling. When we talk about paralleling, we're talking about tying sources together, right? The simplest way to think about it is if I had multiple batteries, I just keep adding more batteries together to give me greater power, right? So you generally parallel generators together or add them together. There's a couple different reasons. The primary reasons that we see people do it is to increase capacity, right? I take A plus B, I've got more, right? 5 plus 5, I've got 10. I'm good there. And so I'm able to increase my capacity. The other reasons you would parallel would be maybe I'm looking for redundancy, right? I've got 5 plus 5 plus 5, so I've got 3 5s. My critical load is only 5. So now I'm N plus 2. I could lose a unit because these things are not infallible. It doesn't matter what paint color it is, every generator has the potential to fail, right? That's just the nature of it. This is a very large 1800 RPM electromechanical device that burns fuel. It's got all kinds of components. There's a chance they're going to go wrong. Nothing you can do about it, right? It's just time. It's corrosion of controls. It's all the different reasons that things can go bad fuel, whatever. Generators can fail. So you might parallel for redundancy. You also might parallel for serviceability, right? I can know that if I've got redundancy built in, I can bring a unit down and maintain it and serve it while still making sure I have enough capacity to serve my load. Now, way back in the day, what we used to do is we used to exclusively use paralleling switchgear, right? There are 3 major vendors that we would work with, and we would do paralleling switchgear with these guys. And it cost between $50,000 and $70,000 per generator to parallel generators together, right? We're talking big hospitals, big water treatment type processes, people who just need that power and have the deep enough pockets to spend that money, right? But they're not the only ones that really needed that critical power, right? There's smaller people who redundancy and expanding for capacity is just as important, but they can't afford $50,000 to $70,000 for the generator plus 50 to 70 grand per generator to tie them all together. So back in around 2002, and I want to preface this by saying that a lot of those controls back in those days, based on technology, were very analog technologies, old school stuff, right? Hundreds of wires running back and forth with a little bit of voltages going here and there. Generac took that concept and just said, well, If we can figure out how to do this digitally, it becomes a lot easier and a lot cleaner. So instead of having this big cabinet that costs $50,000 to $70,000 with a whole bunch of really smart components that have to be able to talk to one another, if we can replace each of those components with a chip on a board, suddenly I got a board that's about 12 by 12, well, I've got a paralleling board, right? So Generac came up with what we call integrated paralleling, or our brand or market name is modular paralleling systems. That board is now small enough to be mounted on the generator. And along with a switching device mounted on the generator, all you need for paralleling a generator is built into that unit. I don't need that switchgear anymore to be the brains of the operation. I still may need that as what I'm going to call a collector bus, a place for them all to physically tie together, because eventually that has to happen. The wire's all going to land at one spot. But now I can put generators together and do it more cost effectively in a digital way. And once it's done once digitally, you know the settings from one, you can just put it in the next one and put it in the next one. I used to do paralleling switchgear projects in my startup technicians. I mean, we'd be out there for 2 to 3 weeks because in the analog world, you're just tweaking, trying to get things to go, right? You're playing with it here, playing with it there, trying to figure out, you walk out to the generator, then you walk back to the gear, you turn a knob and you go back and you just do this for weeks to get it all to work just right. It was the black art of paralleling generator. And so we just took it into the digital world and made it a lot easier. But then it became small scalable, where I could parallel 150 kW generators, or I could parallel 500, or 1,000, or 1,000 with a 500. None of that really matters. Size doesn't matter. So that client who isn't the huge hospital, isn't the big data center, but still cares about redundancy, right? I mean, their stuff's important too. They just don't have those huge deep pockets to spend millions of dollars on stuff, but they need it done too. Now they could take multiple 300s. Like I have a 300 kW gas generator sitting on top of a grocery store in downtown Philadelphia. I don't know, I can't tell you why the grocery store needs levels of redundancy, but they're actually N+1. They have a redundant generator, sits on the roof. It's a very cool picture. But I mean, why they needed that, I don't know. But their business said they needed that, and they needed redundancy. And otherwise they would have bought, I don't know what they would have bought. They would have bought just like one single 600 kW and crossed their fingers and hoped everything was fine. By giving them 300s, they still meet the 600 need with some redundancy.
Yeah.
Right.
Well, one thing that I think is fascinating, or at least helps make a business decision here with parallel generators, is sometimes I don't need 2 megawatts of power today, but my future plans are in the future, maybe 5 or 10 years down the road, I'm going to need that power. So today I can buy just the 1 megawatt generator, and down the road I can buy another one.
Absolutely.
And I can parallel them together at that point.
Yep. Paralleling for capacity and having expandability, right?
Yep.
Being able to have a provisional generator set and then being able to add generators to it, right? You've got to put the infrastructure in first. But yes, that's the thing. It gives you scalability. I moved into this building. I know how much power I think I need, but I happen to have a lease, an option on my lease to take over this other property that's right next door, right? So, but I don't want to put a 2,000 kW, I don't even know what they cost today. I don't want to put one huge one and only use 30% of its capacity for years on end, because now I've eaten up a lot of my capital capabilities, right? So I had a customer actually who did this, a bunch of distribution centers, and they built one in Cleveland and like one in Boston, and they bought 1750 kW generators, thinking that things were going to grow. They never got over 500 kW of load. And the designer, so mad at himself for not looking at other solutions. He built a new data center in Atlanta. We backed up all 3 utility feeds, and there's a pair of 600s at each utility feed. He's never added that another one because they've just never needed it. But it was the point where he didn't buy this massive generator that they didn't need. They were able to just buy the equipment they needed for the time. And if they ever expand, they're good. They don't, they don't.
Well, that's a great story. Well, John, you've been fantastic. I know we're running short on time. Maybe, but to wrap up here, you could maybe give us a little bit of a background on what are some of the mistakes you're seeing people make in the market today, and how can they prevent those mistakes from happening?
I think when we talk about mistakes and challenges, I'm going to speak specifically to a couple different technologies and things to deal with.
Yeah.
Is from Generac's perspective, from my perspective, the number one issue we run into today in installation of generators is gas generators are a much bigger thing than they used to be. gas generators are a big consumer of fuel when they need it, right? We are a low pressure, high volume product, right? Which means when my generator starts, I'm not burning that much fuel, but as soon as these loads kick in, the generator's got to respond and suddenly I need a ton of fuel, right? I'm a car and I'm just cruising along and all of a sudden I've got to go uphill. I got to stomp on the gas to get going. And what we see is people not recognizing how much fuel we need and putting in gas infrastructure big enough to handle it, right? And I don't want to disparage it. We have documents that can help people guide through. We have installation guides, we have gas instruction guides. But usually what happens is the people who are doing the gas system are very used to things like boilers, right? Hot water boiler. That's the biggest thing that people use natural gas for in a building. And a boiler, when the water gets colder, we've used some of the water, you fill it in with fresh tap water, right? Now they got to make that water hot. All they got to do is make that flame a little bigger, right? They're just modulating a flame here and there, and it's not that big of a deal, right? Well, I'm sitting here as a generator and I'm running at 10% of what I need. And all of a sudden you throw a bunch of load on me and I'm at 80 or 90%. I need to go from nothing to a lot. And that piping system and the regulator that feeds it need to all be adequate enough to do it. Like you need to build for 50% more than the generator really needs so that it is sufficient to deliver all the fuel the generator needs. Because I'm going to suck that pipe dry if you can't get me enough fuel. Right? That's the number one thing that I run into in my day-to-day business is we put generators out there and people don't, I'm going to use the word respect, and that's not probably the right one, but they don't respect the nature of the fuel profile of the piece of equipment. They just go, I think an 1.5-inch line will do, and we're good, right? And I'm like, no, somebody needs to put pen to paper, recognize the amount of fuel, how long that pipe is, and how fat of a piece of pipe you should get, right? I don't want to disparage people to do it, but that's what we see more than anything else.
Is that a problem that could be solved through the design engineering process? Could the consulting
Absolutely.
engineer specify that? And should that be something, I don't know that it's within their scope. Let me take that back a little bit. I anticipate it's in their scope, but maybe something that's easy to overlook.
It's totally easy to overlook. Here's the thing. A generator is an electromechanical device. It's got an engine that drives a generator, right? But in the bid spec world, in the building construction world, it's considered an electrical piece of equipment and is typically sourced through the electrical contractor. It is designed by the electrical engineer and the electrical designer. But I'm talking about the fuel system. That's the mechanical guy. He's on the other side of the wall and he doesn't know what's going on. He doesn't know what generator's done. And that really falls in the responsibility of the mechanical engineer and the mechanical contractor, right? And again, what happens, the electrical contractor puts the generator in place and they turn to the mechanical contractor and they say, all right, hook up the fuel line. The mechanical contractor goes, well, I have money in the job for that, or hadn't planned on doing that, or I got a guy. Let me call my gas guy. That's what they always say. I got a guy, right? Everyone has this gas guy that drives around and does everyone's gas, right? And he's been doing it for 50 years and knows gas better than I've ever known and whatever, right? So that's the guy who doesn't recognize this because they didn't plan it. He just came out and he saw that my generator had an 1.25 inch fitting on it. He's like, well, if it's got an 1.25 inch fitting, then that means it probably needs 1.25 inch pipe. So he puts, a 30-foot long 1.25 inch pipe that's just not sufficient to deliver the fuel and walks away, right? And now on our 5th or 6th trip out to the job, we keep telling them we need to get fatter pipe. That's where the ugliness gets, because you guys know this, right? The generator is one of the last things to get put into service in a building, especially if it's a gas generator, because you got to put it in and you got to build the fuel infrastructure. So it's Wednesday and you get a call that says, well, come on out tomorrow and start up the generator because we need to get our certificate of occupancy on Friday, right? And you get out there and the fuel line is nowhere adequate for what you got to have. Maybe it gets enough to start the unit, but not to put any load on it. And now it's next Wednesday and everyone's yelling and screaming because we're 3 days past the CO and they needed to get. No one can move into the building and the inspector's not going to let you move in until the generator is sufficient for what we got to do. Okay? That's the reality that you see, and that's a very big pain point. Another big pain point, again, from the design standpoint of things that I run into, understanding fire pumps, understanding requirements of fire pumps, and how that acts on the generator, and knowing that the fire pump, what controls are on a fire pump that can change its profile with a generator. Fire pump gets delivered to a job site. It gets started up by the fire pump guy. It's run on utility. It's all in the default factory settings, which are not good for the generator. And the guy leaves. And then the generator goes out and we get that started up. And now they want to do the test of the fire pump on the generator, and they start the fire pump and it buries the generator. Generator can't handle it. The engineer looks bad because they're like, well, you undersized the generator, obviously, because the generator can't handle starting the fire pump. Right? Well, that's not the case at all. The fact that the fire pump still has factory settings. No one went in and said, well, we wanted to limit that soft starter to a 350% or 400%. It's still sitting at 600%. It thinks it's across the line. It's burying my generator. Right? Well, we can't go in there and play with the guy's soft starter. We can't play with this thing.
Sure.
Now you got to bring the fire pump guy back. And again, we're not getting our CO, and everyone's frustrated and upset about the whole thing.
Yeah, those are two helpful things that I hope will give some guidance to people who are in the field where they have problems.
Yeah, and the other thing is just if you step way back and you look, what we want customers to do is, pick up the phone and call, and let's at least have the conversation. Right? Are we going to be all things to all people? Can we solve everyone's things? No. But I can tell you who to call, or I can give you some guidance to put you in a mind frame of what you need to do next, right? So that you can start this energy journey. That's really what you're on, right? Because we're dealing with operating expenses, not capital expenses. So let's figure out what do you want to do? What do you want this building to do? If you're okay paying high energy prices, okay. If you're not, if that's constrained, let's show you what kind of assets can get you to a place that you're more comfortable for your long-term spend.
I think that's great. And it's one thing that I think is very apparent with Generac from our experience as an industrial dealer is Generac focuses on these types of systems and nothing else. You're not making engines for trucks. No. But you're also very willing to be a partner. And what I mean by that is it's a very approachable partnership when we have a challenge or a problem that we can talk it through and have a solution. So for a potential design engineer or a facility manager, it's just that simple. What we've talked about today, there's a lot of complexities about
it. It's not going to get easier.
It's not going to get easier. And if there's anything that I've more reaffirmed in after our conversation today is the importance of a good partner to help guide you through the process.
Fair enough.
And I feel like that's something that is unique to Generac compared to others.
We're willing to help get in your business. I don't know if that's the best phrase I want to use, but that is the thing. We want to help your business. We're willing to get dirty with you and figure it out. And what's the best solution? I'll give you one quick last example. We did a big project in Minnesota. This customer is 5 miles from Canada. They have very bad power because they're at the end of the line, right? And we spent months working with them and modeling what they do and coming up with solutions and talking about, frankly, there were some government incentives, there were some state tax incentives and other things we helped them research to be able to come up with what was the most attractive solution. And in the end, was that the most profitable solution for Generac? I got to be honest with you, no.
Yeah.
There were two competing things, and they went with one. We're happy with both. Don't get me wrong, but one solution was a bit more profitable because it had a certain content of product. One was a little bit different. We went with the one that was different because it was the best one for the customer. In the end of the deal, the product was Generac product, and the customer's happy with what they got. And we'll go on and move on to the next customer, and we'll solve their problem too, right? It's got to be what they need and what's the best solution, right? Again, my title is Director of National Power Solutions. I'm here to make solutions, and I think Generac's got plenty of options to get you a solution. We'll find you the right one for you.
Well, that's great, John. Thank you for being with us today. Really appreciate the conversation, and until next time.
Thanks.